November meetup. Hello again. We weren't broadcasting before, so this is the Angular meetup for St. Louis, November meetup. We're going to talk about automation today and then a comparison of the top 3 web frameworks. So here to present first, we have Dylan Schulte with Bullhorn, and he's going to take it over.
Yep. Just go ahead and share my screen. All right. So we already just kind of went through an introduction, but I'll introduce myself again. So my name is Dylan Schulte. I'm a QA here at Bullhorn. I've been a part of our last 2 major product redesigns here at Bullhorn, and thereby we had a leading role in building the end-to-end automation tests that we created to ensure the ongoing quality of our product. Tonight I'm just going to cover sort of a quick progression that we experienced as we built out our protractor end-to-end tests, as well as showcasing what the current state of our suite looks like to hopefully give insights on what didn't work for us and how we focus or how we found success with our automation. So this is kind of that timeline that we're going to cover tonight. I wanted to start with sort of the learning process that we went through with our early iterations of the protractor suite, and then hitting on some of the major improvements we came to as we became more familiar with the framework, finishing up with what we're currently working on to further refine our tests. After this, I'll finish up with some questions or anything like that, as well as give some more concrete demo stuff, show you guys some code and things like that. So when we were first doing our new Angular app and everything like that, we were coming from an experience of a Cold Fusion-based app, in which case we were using the Maven WebDriver version of Selenium. And that was actually one of the reasons why we decided to go with Protractor initially, was because we were already familiar with Selenium from the legacy app automation. And so as part of that, we were actually familiar with some of the difficulties that come with using Selenium, but also the good things as well. So because we create, destroy, and reassign iframes so much in our app, we knew that there was going to be some extra work that had to be done around handling those frames and navigating back and forth between those, as well as the fact that we have to add a little bit more around dynamically waiting for elements to appear and disappear, because Selenium doesn't really handle that super great. On the other hand, we already had the bulk of the configuration set up, prepared to integrate into our automation server, Jenkins. And a majority of the team also had a basis of understanding and using Selenium just from using it in the legacy automation app that we were using. So we definitely felt that despite some of the downsides of using Selenium and everything like that, it was a better fit for us moving forward and going into Protractor. So once we started using Protractor, while we had that knowledge base of using Selenium in the old app, there was definitely a lot of growing pains in converting that Selenium knowledge into a practical application of using Protractor, just simply because while the experience gave us a head start, the differences between those were substantial, particularly around the configuration file and the test layer structure. Protractor leverages Jasmine as its test layer framework, and so that looks completely different from what we were doing in the Maven WebDriver stuff. Excuse me. So as we became more and more familiar with the basics, and once we got to know Protractor a little bit better, we had to come to a decision on where we were going to put our automation. Initially, we thought it might be better for us to start in the base app where all the rest of the code was going, because that would let us, kick off modules in isolation, test those modules, and then, shut them down and do everything piece by piece. But we felt that we were actually going to have more value from keeping the automation repository as a separate section completely, so that we could test the app as a whole and go through navigation and workflow in a much more systematic and user story-based approach. All right, so getting the repository into a known state was sort of the next thing that we had to take care of after we converted over to Protractor. So like we mentioned, Jenkins, our automation server, was already sort of configured to run Selenium. It was already built to set up a Selenium server and all that sort of good stuff. So this was actually some of the easier parts of the progress of moving into Protractor, was getting the suites that we were building to run within Jenkins, and then to sort of finish off that whole project, we wanted to also add a dashboard that would consume and report the results that we had on our nightly runs that we were kicking off through Jenkins. Once those reports were built in the automation dashboard, we then also integrated that into our Slack channels so that teams could be notified across the department of their automation passes and failures overnight, things like that. So once we had the reporting in place and we sort of knew what needed to be done with the automation and where we were going with it, we wanted to be able to keep up with the expanding app, but also improve the behavior of the existing stuff that we had to build quickly to sort of get up to speed sooner. So now that we had some room to breathe, we had a laundry list of things that we kind of wanted to do with this, all the things that we could optimize, we could prioritize, and things like that. But at the end, we landed on removing, trying to move away from the static data dependencies that we had, which would give us the most sort of bang for our buck. It was the lowest hanging fruit. So we wanted to separate our tests from the static data within our development environment that we had built. And to do this, we built out a util class that leverages the REST API that's a part of our application to form these three core functions that were pretty crucial for us to increase the stability and reduce the flake issues that we were having with the automation at this point. So those three values were the data generation, the data manipulation, and the data teardown, all which are very crucial because if you can create the data, test it, and then get rid of it afterwards, you're in a much better state. You don't have to worry about, what's up?
Would you categorize what you're talking about as like buzz testing maybe?
I'm not super familiar with the term itself, but
so, are you generating test data to check edge cases and parameters? Is that what you're talking about here? Or is
so,
different?
Right. So in this situation, the REST API was being used so that we could do all of our workflow testing and things like that with data that's dynamically being built. So even from the most basic features such as creating a new record or deleting all the regular CRUD operations, we wanted to make sure that we weren't sort of building up this backlog of data that was never being used or reused and things like that. And so in order to do that, we leveraged our API so that when our tests were starting up, instead of going and navigating to pre-existing data and data that was just sitting in a database somewhere, we were creating that data on the fly so that we could then navigate to this data that we freshly created, knowing the state of it. And then once we were completed with the test, instead of leaving that just in the database to rot forever, essentially, we cleaned it up, and that way we can reduce the size and load times and all that sort of stuff that we're not testing within our databases and things like that.
Okay. And we have a whole bunch of different settings and how things are, so that they use this util to switch those settings, and then when our developers are using those same environments, like our automation is going to fail because they changed someone's last name. But if they're always working with pristine data, they know what it is. They know what they need to actually expect.
Do you use mock data in your testing process, or?
So that's sort of what we're trying to navigate. So similar to how you create mock data for like unit tests and things like that, we wanted to sort of reproduce that behavior from a UI and end-to-end standpoint as well. And so instead of spinning up a local server with mock data and all that kind of stuff, instead we found a better way of doing, we found it was better for us at least, to leverage the API instead, to basically create mock data that was in that pristine state. Yeah. All right. So now that we had the more stable tests and the reporting structure to notify us of any changes being made to our pre-existing code, our next big step was to make a structure so that when new automation was being built, that there was an easy way to get the most out of each line of code that we wrote. And the way we wanted to approach that was through the structure of creating common files with shared data tests, shared data sets, and then converting from an entity-focused suite creation to a feature-focused suite one. Which, to give a little bit better context, previously we have been saying that, if you have this entity that has a whole bunch of different features associated to it, we would run our automation suites that would test that entity itself from top to bottom, whether it's creating the entity and manipulating it, working with associations, taking actions upon it. Previously, all of those were within one suite that was sort of working that entity from top to bottom. Instead, we switch our focus over to a feature-based one, which would test one specific feature across every entity that it applied to, which was good for us because it allowed us to cut down on the automation runtimes because they were more consolidated and more concise. And it also made it more clear about when we were getting failures, that if they are failures across a specific entity or if they are failures across a specific feature. All right. So the next logical step after we started implementing these common files was to create a style guide that summarized all the things that we've been working towards over the course of the project. From the page objects to the test layers, we wanted to make it clear how our files were structured and how they intertwined with each other. On top of that, we wanted a simple outline on how our methods would be built to ensure a streamlined and consistent approach to interacting with the app. With the style guide, we've empowered our code reviewers to provide those still learning the ins and outs of our ever-growing code base, a quick reference guide to help them add to our repository without compromising the integrity of the tests, which is a really fancy way of just saying we wanted to make it so that it was easier for people who weren't familiar with the system to help us build automation and work with the system without needing to spend a long time to get on board and start really getting into the guts of it. And I was planning on showing the style guide afterwards, just to give a little bit better context on that. So that kind of brings us to where we're at now with our automation suite. As with all projects, there's always work to be done. There's always progress to be made. So these are 3 of our current projects that we're working on as we work towards making our tests even more extensible, so that we're further simplifying upkeep and maintenance of our code base. Dynamic data validation methods grab the app within its current state, take the data that's grabbed, and then validate the manipulating data into an expected state. So an example of that would be we have a lot of list tables in our app that we need to validate that sorting and filtering work within those. Instead of using seeded static data that we expect to be there that we want to plug in ourselves, instead we're grabbing the current state of the app, regardless of what that is, grabbing data out of that data set and then filtering or sorting upon it and evaluating from that standpoint. What this allows us to do is it reduces the amount of static data that we require to be running our automation. And it also makes it a lot more stable to prevent other automation from interacting with the data sets, as well as preventing someone coming in and manually updating the data as well. By sort of getting away from the whole expectation of static data existing at all, it brings us into a much more stable environment. And then on top of that dynamic data validation, we also wanted to simplify our test structures with greater extensibility. By doing, to do that, we leveraged our test cases to iterate not just through the entities, but through subsections of the features that share the same functionalities, such as a column on one table is going to work the exact same way as every other column on that table, or something like that. So instead of writing a test case for that specific column with that specific test case, we wrote a test case that iterates through all of the different columns because they all share that functionality, and that way we can still have the same amount of code coverage without having an obnoxious amount of lines of code that have to be maintained with all of that. And then finally, sort of building off that same idea is instead of focusing on static data sets, which we're validating against, we're moving towards having static reference points that we then leverage for these more extensible test cases. Like my previous example, these static reference points would be like the columns that would be showing up on that list, or something to that extent. So that's the gist of what I had for the presentation, and then I wanted to sort of go through some of those things that I was talking about. So the more simplistic ones that we have here are our automation style and structure, which we're using to a lot of success to help bring people up to speed who want to get started on using our automation or want to start building off of our automation, as well as giving those who are reviewing our automation commits better references so that they can validate what they're doing and what they're allowing to come into our system as well. Along with that is our automation dashboard that we use to return our nightly run results. This is a locally run server that we have that consumes the reports from our Jenkins automation server, prints them out here, and then we also allow ourselves to be notified through this as well, through our Slack channels and an integration from that side. I didn't have Jenkins pulled up, but I can just sort of show that really quickly as well. This is sort of what our automation suite looks like. As you can see, we have a whole gigantic list of all of it, all of which is primarily focused upon feature-based development, whether it's adding interactions, finding data, lists, etc. We've broken this down into a feature-based thing to, again, focus on quick, iterative, easy to manage test suites that are allowing us to get a better grasp of the state of the app. Then finally, I wanted to show a little bit of our code base as well, to sort of show what our automation suites look like in the current state. So the common pages that I was sort of mentioning are, on one hand, our page objects, which leverage all of the methods that we need to interact with the app, grab the state of the app, et cetera, et cetera. Primary things that we use in almost all of our tests are these waiting for elements. Like I mentioned, Selenium doesn't do a great job of handling an element not being there when we're expecting it to be there, or showing up late to the party or things like that. And so we've built our own extensions to the Selenium WebDriver to allow ourselves to be sure that an element exists before we try to take action on it, and ensure an element disappears before we expect it to be gone. And then on top of that as well, these are those extensible small test cases that we were talking about. So in this situation, like I was talking about with a list test, for example, in this situation, we have our columns that we have in a known state. They're not going to be changing anytime soon or anything like that. But then we iterate through those for all of our test cases to validate that the column is sorted. We have things like that. And then the extension of those two pages come in the form of our entity-specific pages or our feature-specific pages. So like what we were just seeing in the end-to-end test, we have these methods that both validate from a JavaScript sorting perspective to validate that the data that we've grabbed is actually sorted, and then also returning that data as well. And then lastly, the end result of that whole thing is what our dedicated end result is, that with the extensible test suites and all that sort of stuff, we can leverage these common classes across whatever entity we need to. So it's a very simple, clean look to our automated test structure. What's up?
I'll admit I'm not in the testing world, be it unit or end-to-end and automating all this. Where did you all? This is a really cool approach to this. Did you all? This come from like an article you read, or is this like something that you had a weird acid trip and came up with? Like, where did this concept come from? Not basing it off of entities, and instead doing something that's much more iterative and robust, really, like this.
Yeah. So it kind of came organically, if I'm being honest. It was, when you're jamming on this sort of stuff day after day after day for, well, it's been about a year and a half now since we started working with Protractor. You kind of just find what works best and what's not working, even more importantly. Our system is very robust in the terms of what it can do and what sort of data it stores and all that sort of stuff. And so it came to a point where, because our sort of base entities were so large and could do so many different things, that it wasn't really feasible for us to say, well, I'm going to test, this placement from top to bottom with every sort of, action, everything that I could do with it. Instead, we wanted to keep them into small little compartmentalized pieces that could be easily leveraged in more than one place. And so that's sort of how we got to that feature-based approach.
TypeScript really unlocked a lot of
it's definitely been a very big boon for us, for sure. In our flagship product, the one that we started that spawned the protractor automation focus for the department, we're not actually using protractor right now. We're still just using, we're not using TypeScript. I misspoke. We're not using TypeScript right now. We're just using JavaScript for that part. And while the functionality is essentially still the same, because for the most part, the TypeScript really helps us leverage making it very clear and very concise what it is we're expecting to get out of our methods and what we're expecting our methods to do, which we think can then leverage within our tests in a much more generalized or extensible way.
And it also helps like developers get up to speed with our automation faster, because we have really robust page objects that with really defined like functions of like how to select things. So in our old flagship product where it's written just in ES6, they'd have to like go and know the page object and then use it. Here we're able to get the IntelliSense of like, oh, here are the methods I have on that. I can use this to kind of help me.
Yeah.
So we're avoiding a lot of duplicate code that we had before in the ES6 variant.
Do you have a rough idea now that you've sort of rewritten this, if you were to have, I guess, how many lines of code, what percentage would you say you reduce by maintaining the same level of coverage?
So if we were to be able to implement this across the entire app, we could probably reduce it by about 50%, the amount of code that we have written. And that's just the beginning of it. I mean, we're still working on making more and more of our test classes extensible and generic like this. And we're just sort of scratching the surface of what we can do with it.
Awesome.
Yeah. Cool. Any other questions or anything like that?
Can you just do like a brief overview just of what protractor is, and like what a page object is?
Sure. Yeah. So I kind of skipped or the more simple parts, I guess is a better way to put it. But so protractor is a automation framework that leverages Jasmine framework, which is a unit testing framework, to take action upon the browser with an automated WebDriver called Selenium. The way it does that is through JavaScript methods that take action, whether it's clicking or dragging or typing or entering or whatever action you can think of that you could do in a browser. Selenium, which is the core framework that it's leveraging for you with the methods that it creates. We store all of those methods that take action on the app or return data from the app in our page objects, which are essentially these giant method files that have everything that we would want to do for a specific section of the system. We then leverage those page objects in our test layers, which would either include a common layer, which would just describe basic functionality, or the actual tests themselves, like I was showing here. Top of those would be an entity test layer for us, which would be the specific subsection of the system, the specific subtype of record, for example, that we would be taking action on. Yep.
Anyone else have any other questions or anything about automation?
I think you mentioned like your picture data is generated on the fly.
Mm-hmm.
How does that work?
Yeah, so our app has a REST API, a RESTful API service that allows us to create, read, update, and delete data on the fly and insert it into the database or read it from the database. Leveraging that, we then can create a record that we need to test on it, and then either change the state of it with more API calls or clean up after ourselves by deleting the record with.
I'm specifically curious to see how that's set up.
Sure. Yeah. Let me just show another quick section here. So for an example, So this is our REST util that we're using in our automation right now. It leverages request promise and Bluebird, which you can see at the top. And what we do here is a candidate is an example of one of those entities that I was talking about in our system. And so we leverage that and create export classes that can do all these sort of actions with that data that we need to do that isn't UI based. So essentially they're backend calls that we can make on the fly in our automation to change, create, update the data that we're looking for. And then what that sort of looks like in our automation suite would be sort of like this. In this situation where we have a function that creates the test data, in which, and you can see here, we're actually doing the cleanup as a part of the data creation as well, to sort of just make sure that we're never leaving anything behind if the test were to fail or something like that were to happen. So in this situation, we delete a candidate that has a first name and last name that we know, and then afterwards, same type, so that there's only ever one in the system, and we know that it's coming from that state. And then another example of this from a data manipulation standpoint would be we have some more complex entities that can't just be created up on the fly. They have a little bit more data associated with them that isn't really feasible to just create at the start of a test and then clean up after itself. And so in those situations with those records, we then update them to be back into the initial state that they were at before we took action on them. Yeah. Yeah. So like I was showing initially, those common pages was, this is an example of one of our page objects. I'll kind of make it a little bit smaller just so it's a little bit more of it. But this page object is what we call our common page, which is essentially the most basic of basic actions that we can take. That's why we have these waiting for elements to exist. As some more things that, again, we have to update or extend from Selenium's methods that it has built into it. We have scrolling, waiting for elements, returning data, finding elements, and things like that. Those are all stored in this common page, which is then leveraged or extended by our more complex feature pages, which you can see here. So this is our list page, which leverages all of our, and we have our getters and our setters and our public methods all nestled within here, so that whenever we want to take action on a list in our system, we can refer to this page object, get an element that we need to find, take an action on one of those elements, or something to that extent.
How do you find the elements? So I see you back here using an element in by CSS.
Yeah.
You're not using like a XPath or ID?
Nope. So we just use CSS selectors to find these. So one thing that we've able to work well with our developers who are building the app with is implementing data automation IDs across pretty much every ID that you can think of, or every element that you can think of in the system. And so as we build a new feature, or as we build onto our application, whoever's writing the automation, if it's not the developer who's actually building the app, because it normally is not, we work with them and say, hey, I need an automation ID on this element because I'm going to be taking action on it in our automation suite, or things like that. And so from the very get-go of building a feature, we're already contemplating how we can make this work with our automation, and how we can build automation around it, almost in a sort of TDD sort of approach to the automation framework.
And with those data automation IDs, they're just an attribute on the HTML tag. And that allows us as developers to kind of change the tag that we're using. We can change a div to a span, and it's not going to break automation. We can add class names, change class names, and as long as we're using the data automation IDs as selectors, it's not also going to break automation. So we have a lot of leniency in how we're developing the UI, so as to not break automation.
So those data automation tags get stripped out when the application goes to production?
No.
No, because we actually run automation against production environments as well.
Does that introduce security holes then?
No, they're just generic IDs. So like here,
Right. So here's an example. Yeah.
So like here, data automation ID. This just is the custom range picker. So like if you were to look at the HTML, like if you had an ID or an attribute name on there, like there's no indication of what that does. It doesn't give you any leverage into the system to kind of do whatever you want.
Yeah. And a lot of times we actually often use labels that are already visible on that we're already displaying on the front end as well. For example, we have a calendar picker in our app, and each of the days of the week and everything like that all has an automation ID that's just the day of the week.
If you're testing in production, that means the automation framework is in production as well.
No, our automation framework lives first, and basically we just in Protractor you say you want to load. I want to load this into the browser, so you just give it a different URL of what you want it to run in the browser, and then it'll run in there.
It automates your browser, so you can be on AWS or Amazon server or someplace on a different country. It's basically just like someone can click.
This is another benefit of separating our automation repository, in isolation, is that we're not shipping all of our automation code with our production code or any of our app code at all. It's all completely separate, and this is also beneficial from an automation standpoint in that we can then have separate branches, separate tags for different stages of the development process as well, and different stages of the deploy process.
Now, it looked like when I briefly looked at Protractor, you could kind of grab elements by the model they were bound to. Is there a reason you guys chose to take it more about the UI side of it than the actual back-end Angular side of it?
But a lot of our steps that we're using to display that was good in like the AngularJS plan where you use like ng model and all of those kind of. With Angular 2 or Angular now just being more like their forms are the reactive forms, so you don't really use the ng model, different places, and all of that kind of stuff. So we went with a route of sprinkling data automation IDs around so we can get more granular on our selectors.
Cool. All right.
Alrighty, we'll jump to the talk number 2. Let me go share my screen.
Muted. Alrighty. So let's share this guy. Jump over to my talk. So talk number 2 of the meetup is we're going to do a comparison of all the different, like the top 3 web frameworks that are out there right now. So we're going to go over Angular, React, and Vue.js. So just a little asterisk on this talk, like I'm very knowledgeable in Angular, not so knowledgeable about React or Vue. I learned them just to kind of do this, which was fun. And then the first couple slides are a little bit dry because we're just comparing and contrasting all 3 of the different frameworks. So couldn't really think of a really fun way to present the data, but we'll give it a shot. So like I said before, my name is Joshua Godi. I'm the principal UI engineer here at Bullhorn. Primarily do front-end developments, sort of monitor like our build cycles, make sure our bundles are as small as possible for when they go into production. So, and if you ever need me, hit me up with any questions. You can hit me out on Twitter. It's just Joshua Godi on Twitter. So here are the top 3 frameworks that we'll talk about tonight. We have Angular, React, and Vue. So the current versions of all of those, we're on Angular 5, React 16, and Vue 2.5. And we all know that Angular is sort of backed by Google, React is backed by Facebook, and Vue is written by an individual developer called Evan Yu. But he does have some big name companies sort of backing him to supporting his development efforts. So when I talk about the different size, like I have a couple slides that are kind of like this, just kind of comparing, contrasting the different pieces. So this gzip size is just the size of the framework itself. We noticed that Angular is pretty massive, but you'll notice later on when we actually build it for production and all of that, that's where we'll see a lot of the benefits of Angular. So initially, it's pretty big to download, but that's mainly just for development reasons. React at 23K and Vue at 43K. So Vue is a little bit bigger than React, but React is the smallest. Yes.
I know that Angular has made large strides in trying to modularize a lot of their sections of code, and now you can even opt out for large sections if you want just super minimal core. Does that affect?
Yeah, it'll affect this. Basically, this has like you have core, you have HTTP, you have the router, and sort of that's where I kind of got that number from. But yeah, Angular has made it where you can kind of opt into all the different pieces. So just like React with it being 23K, that's just React. That doesn't give you like the router or any HTTP or any sort of state management system with as Angular. That those kind of come along with it. So as you start adding those add-ons, especially even with Vue, you're going to get bumped up. But then you'll see at the end when we kind of build our sample application for production what the gzip size is, like what you would actually send to your server. It's pretty small. So Angular kind of coins itself as like one framework to rule them all. So it works good on all the different kind of browsers. It's not really coined as like an MVC type framework anymore. It's just sort of like a web framework in general. React coins itself as just a JavaScript library, and then you have to add on all of those other different features to sort of, you have to add your model. It only does the view layer. It doesn't do any much more. Vue does coin itself as an MVC framework. They're all MIT licensed, so you don't have to worry about anything kind of jumping up at you on those. And then the IDE support for Angular is extremely great. VS Code and WebStorm have a lot of integrations in there to help you with TypeScript. A lot of that IDE support for Angular comes with it being written in TypeScript, so it's able to kind of jump to definition and all of that kind of stuff that you do in Java programming language. You can do that with TypeScript. React is pretty good. It's not the greatest. You need special plugins, format your JSX files and all of that correctly. Or you can be like me and turn your formatter off because it was just putting everything in one line and very annoying. And then Vue, since Vue is pretty new, the IDE support for Vue is pretty minimal. There's basically some extensions out there for like VS Code and WebStorm just to do syntax highlighting. But since Vue does break up their different sections pretty good, like auto formatting in your IDEs will actually work, so that's pretty cool. And then Angular comes with a really good CLI. It has CLI that help you generate components, services, all the different building blocks that create your Angular application. React, I couldn't really find a really good CLI out there for React. There's some starter kits that you can kind of clone and tweak around with. There's a Create React app node tool that allows you to create and scaffold a base application, but no real code generation after that. And then Vue does come with the Vue CLI. I didn't see a lot of code generation for that, but they had kind of obfuscated a lot of the Webpack-D stuff, just like Angular CLI does, which was pretty cool. And then, so Angular is primarily written in TypeScript. You're able to write Angular in ES6. That's what we actually started writing Angular in ES6, and it was horrible. We made the switch to TypeScript, so I would definitely recommend that. React, you're going to be writing this in ES6, and Vue, you're going to be writing that in ES6 too. And Vue, and I'm pretty sure React, like you can write them in TypeScript. You just have to transpile them and then compile them with Babel. They're all 3 component based, so you're going to be writing components. You're going to be thinking about your application. You're going to be taking a look at your application, figuring out like, okay, I need a header component. I need a card component because I have cards all throughout my application. I need my card component needs a footer component, and sort of with all of these frameworks that we're going to be using, you'll have to start training your mind in order, like when you see a web page or a mock-up from your UX team, like what components you can make, what components you can make reusable, so it kind of saves you in the long run. Angular uses the shadow DOM, and what the shadow DOM is, it's basically like an it kind of obfuscates all of your CSS styles of your components so they don't bleed out into the application, which is pretty nice. So we can write components, and if in our component HTML we had an H1 tag, and then in our component styles we said background color red on that H1 tag, it's not going to change all application to be background color red, which is pretty nifty. And there's a couple of different ways that Angular handles the shadow DOM. Like you can do native shadow DOM, but there's right now, especially if you have to go back to like IE 9, 10, 11, or you can do emulated shadow DOM where it just does a whole bunch of property selectors on your class names. And then Vue and React will use the virtual DOM instead. So what it does, it basically, when you create your templates and all of that, it creates them in a virtual DOM and then passes that to the browser to actually render in the browser. Angular does not have a immutable state by default, but you can add like immutable JS to sort of help speed up your Angular application, and then React and Vue will have an immutable state. And then for testability, Angular comes, if you use the CLI, it comes out of the box with Jasmine. So you use Karma for your test runner, and then Jasmine as your assertion library. And then React will use the Jest testing framework, which is a lot faster than Jasmine. And you can actually convert your Angular applications to use Jest if you want to. That's what we do here in some of our applications. And we see like upwards of 60, 70% speed up time in how we run our tests. And then Vue, it's kind of open to you. So you can pick any sort of testing framework that you want. And this is the unit testing side of that. So like how you would actually test your components, how they set up, how you strip them down, etc. And then with any of these frameworks, you can choose any sort of end-to-end testing framework. You can use Protractor or some of the newcomers like Cypress or whatever fits your fancy on that one. The learning curve on these frameworks with Angular, there's a pretty steep learning curve. I would say it's 1,000,000 times better than AngularJS learning curve. Basically, like you're writing components, there's some TypeScript annotations that you have to learn and understand, but it's easy to learn because you're using TypeScript. You get that sort of IntelliSense as you're writing your code. So you know, like, oh, when I have this component annotation, I can do a style URL, I can do a template URL. You get that sort of feedback while you're developing. And then React and Vue, I kind of rate them. React is a high because everything with React is sort of an add-on. You have to know the React router, the Redux, all of these types of things that you need to build an enterprise-level application. You need to also know those add-ons. And then Vue, it's medium because there's also those add-ons, but Vue.js for me, it was very easy and clean to understand and learn and sort of just kind of get started on what kind of needs to happen. Let me hide this guy. Any questions so far? Yes.
So what is it that makes you rise to the level of Angular React in terms of most popular frameworks? And I mean, what is it? I mean, there's a ton of frameworks out there. So
yes.
What? And I'm new to Vue. I'm not familiar with it at all.
What draws people to Vue over some of the other frameworks is I've heard it described as the the gap between senior developers and mid-level developers is not as steep with Vue as it would be with Angular. Since Angular, you have all of those like advanced level APIs that you can kind of tie into and kind of tweak your application with. With Vue, everything's like simple, it's basic. So if you have a mid-level developer that's really good at Vue, like there's not much better you can get with Vue as a senior level developer. So it as like that gap is smaller, which means more of your developers sort of know the framework backwards and forwards.
So it's the learning curve point
Yes.
of Vue that really is the strength.
Correct.
Okay.
Any other questions? Okay. So with that, there's a couple of we've all used Bootstrap on material design. React doesn't really have a good Bootstrap 3 component library for Angular, but UI Bootstrap does support 4. I think it actually supports 3 as well. There'll be like a mode switch you have there. And then for material design, we'll have Angular Material. And then with the CLI and the new schematics in the CLI, you can actually quickly and easily make your own component library. So like here at Bullhorn, we have actual 2 component libraries that we have in-house. We have one that's open source, closed source that kind of just extends our open source, adds a little bit more functionality. Then we use both of those to create all of our applications here. React, we have React Bootstrap. There's an in-progress project for Bootstrap 4. And then we have Material UI. And then Vue, we have VueStrap for Bootstrap 3, Bootstrap Vue for 4, and Vue to 5 for material design. And they're all 3 really easy on how to create your application. And soon you'll be creating your component libraries in something like Polymer or Web Components, and then you'll be able to use those across any of these frameworks. So that'll come in the future talks. So this is a little bit tiny, but here are the kind of the different performance. And then if you just go to this website, you can kind of see, you can add any framework you want. These aren't the latest ones, but this is run on Angular 4, React 15, and Vue 2.3. So it's a little bit dated. Actually, that Angular 5 released, and it's a lot more performant than Angular 4 or Angular 3. So I would expect these numbers to go down for Angular 5. But we see if like we're creating 1,000 rows, it takes about 193 milliseconds for Angular 4, 212 for React, and 166 for Vue. So we kind of see the speed difference in doing those. Highlighting and selecting a row, we see Angular does it in 3.4. This is due to because of the change detection with Zone.js inside of Angular. And then React and Vue are 8 and 9 seconds. And then we get all the way down here where like we create 10,000 rows, and we see that React and Angular kind of React and Angular are kind of neck and neck, and then Vue.js is down here at 1,500 milliseconds. And then the memory consumption, pretty much all 3 frameworks are relatively the same in memory consumption after a page load and after loading 1,000 views. And then here's just kind of the trends right now for GitHub stars over time. I printed this off this morning, I think. So we see that React is sort of growing up there exponentially, Vue's catching up, and then sort of you see Angular kind of steady at 30,000 views, or 30,000 stars, I mean. And then we have some GitHub stats. So we see like total stars, how many people are forking them, how many open issues there are when it was last updated and created. So we see that Angular doesn't get all those stars because primarily you see like startups and all of that are creating sort of lightweight applications, trying to stick with React or Vue, and then Angular is more sort of like the large-scale enterprise-level applications because you're going to be using strongly typed language. It's going to be quickly and easily to make code edits and do some refactoring. But I expect these numbers for Angular to kind of rise up coming up.
Do you think that's kind of a misconception? Angular is perceived as the sort of enterprise level that you have all this power and customization, but frankly, it's once you get over that initial learning curve hump, that it's better or just as effective as React for those like startup environments
Correct.
that are trying to be super agile and have lots of access and customization and move fast.
Correct. I would say like all your developers knew Angular and all of that, they're going to be more performant and like be able to spin things up faster than I would say like React and Vue. But that's my personal opinion. And then this is just Angular. Like this doesn't like there's still a whole bunch of people using AngularJS. They're still releasing AngularJS. I think they just released like 6.5 or 1.65. So like this AngularJS probably has like 50 or 60,000 stars on GitHub. So combine those two, Angular as a whole is sort of in the winning. And then we see NPM downloads, and then here you see more people are downloading Angular Core versus Vue, and then React is just going off the charts there. So we see the trends, like a lot of developers are act as sort of like the framework to go to spin up maybe quick web applications, startups, etc. And then here are just some Google trends. So I just put in Angular, Vue, and React. We see that Vue is actually has a lot more interest over time, and then followed by Angular and then React. So like kind of like the exact opposite of the NPM downloads and the GitHub stars. So go figure. I guess a lot of people are searching for Vue and Google and actually then downloading React. And then this is the nifty thing. So in the US and Canada, most of them search for React. And then you see in South America, Angular. And then Northern Africa, that's where a lot of Vue people are. All right. So now we kind of went through all the boring just table slides to kind of go over what all free frameworks do. I'm just going to show what a simple component looks like in each of them. So here we have Angular first. So like I said before, in Angular you have these TypeScript decorators or annotations to kind of decorate a TypeScript class. That's what your component is. So we have a selector. So this would be the tag name that your component will use when you use it in HTML. We have a template URL and a style URLs. These can also be inline into the component, so you didn't have to have extra files. And then here, in the innards of our class name, our class, we have the functionality of our component. So we just have a count. We initialize it to 0. We have a method where we're going to increment the count. And then in our template down here, the count, and then on this button in Angular, we have the double squiggly brackets for interpolation. We do parentheses to bind and listen to events. And then I don't have an example here, but we use square brackets to actually bind to attributes or inputs in our template. React does this a little bit differently. So we have one file that basically has everything. We're using ES6 here, so we still have classes. We're extending a base component. That component has a constructor where we're passing in properties. So these will be any of the attributes you're passing to this component when you're using it in your render function. And then we have a state of our application. Here, down here, we have an increment function where we're just setting the state was +1. And then since we're in ES6 and this render function is has a different scope, so we want to make sure that when we call increment, we have to do .bind this to bind the scope of our component inside of the render. And then the render, instead of 2 curly braces, we use 1 for interpolation. And then we just bind to onClick, and there's no parentheses, and we just say, hey, you're going to call this .increment, which is a function on our component. And then view has almost the simplest approach. So here we have a new view where we give it an element. So we're saying it's going to grab the ID increment element. We give it a data object. So we're just saying value 0. We have some methods that we're going to be using on our component. And this has an increment method. It's a function. And we're saying this dot value plus plus. And then we have a div. We have that ID. And then counter. We're doing the double curly brackets for the interpolation. And then we have v-on : click. So we use that v-on. So we're binding to something, or we're listening to something. And then the colon, we're listening to that click element or click method. And then we're going to be calling increment. And this will look up the increment method on our methods block that we have. And then it'll call it, increment the value, and then we'll update the value. Any questions on these three guys? Cool. So before we go on to the next one, I have to make sure I start all my stuff. I did this bit when Dylan was talking, but I was so enthralled with automation. And then we're going to go to all these different local hosts because we have a lot of applications. Make sure all of these started. Okay, so this is the application that we're going to be writing. We have a cat list, and then we have a cat search. And then here we have a card here with a button where we can kind of change some stuff. And then here's the Angular version. We have basically the same version in Angular. View, if I go back to the list, and this cat GIF is a little bit crazy. And then this one is the React one. So we're going to be building the same application 3 times and kind of going over all the different steps that we had to do. And then I generated these projects with the Angular app. I used the Angular CLI. For the Vue app, I used the Vue CLI. And then the React app, I used the Create React app tool that they provide. Go back to here. All right, showed what we're building. So here's the CLIs I used. So if you want to reference and use those same ones. So first off, let's talk about and show how each application sort of the files we get once we create with it the CLI or the task runner, and sort of how they bootstrap their applications. So each of these different steps are in different tags, which I'm probably going to have to start and stop these every single time, which is going to be not fun. So we're going to check out tag 1, and then we'll go look at the code. So in this library, which I pushed up to GitHub, so you can go look at it a little bit later too. So we have our ng app, our React app, and our Vue app. If we look at the ng app, the CLI gives us all these different tools. We have the package.json, which has all of our different dependencies. We have protractor and karma already in there for our unit tests and our end-to-end tests. We have this .angular CLI that specifies how Angular is going to build our project. And then under source, we have a main TS. This is how Angular bootstraps our application. So we're actually bootstrapping our app module. And then our app module, this is where we define all of our different components that we're going to be using. So here right now I just have an app component. And then in my HTML, we just have the very basic what the Angular CLI gives us. So it goes from main TS, where we import our app module and we bootstrap it. And then in our app module, notation here for that ng module, where we're declaring that we have an app component. We're importing this browser module, which gives us a lot of built-in tools that Angular gives us, like ng4, ngIf, all of those types of things. And then finally, we're bootstrapping our app component. So when our application loads for the first time, if we look at the app component TS, it's going to be looking for the app root tag in our index.html for us. And then React here with the create React app, we see we have a very, very bare bones application. Our package.json just has a couple of dependencies, so it's extremely lightweight. And then a couple scripts where it uses this tool called React Strips. So it also obfuscates all of the Webpack stuff for us. So we just really have to get down to writing our code. Public, this is where our index.html lives, the manifest for service workers and all of that. Then under source, we see we have an index.js where this uses imports React and React DOM. It has our index.css, and then we're rendering our app components using React DOM, and we're putting it into our root tag in our index.html. And then it registers a service worker for us. And then our app.js, we see here, this is where we're just defining our app component, and in the render function, we're rendering just a div that has the logo and all of that kind of stuff with it. So very basic, and it also has the tests sort of there already for you. So here, just test using the React DOM, and there's not even an expect. So, and then Vue, we see we get a little bit more. Vue uses Babel to sort of transpile all of its code. The Vue CLI will ask you a whole bunch of questions when you set up your application. Like, do you want ESLint? What ESLint rule set do you want to use? Do you want the router? Do you want this? Do you want that? And it'll scaffold up an application for you. I forget all of the questions that it asked me and all the answers I gave it. So it did set up ESLint for me, so I must have said yes to that. The package.json, it does give us the start and the build and doing the linting, all of that for us. We see we only have 2 real dependencies for our application, and the rest are just build time dependencies. So we see we have a lot of that, but not a lot of dev or run our application. And then under static, there's nothing. It just sets up where you can do different environment variables. So based on how you're building your application, you can set up different parameters that you pass to your application. Angular does this with environments, and Vue does this with config, but React didn't give us any of that out of the box with the starter that I started with. There's probably a more advanced starter that has sort of Node and Express and all of that kind of built in for it. We have build where we have all of our Webpack scripts in here. So the Vue CLI doesn't obfuscate any of that for us. It's in our project, so if we need to make any tweaks or we are updating to a newer version, we'll sort of have to maintain that as we go. So it's just another thing that we have to make sure that we're comfortable with. If there's a problem with our build or if our dev environment, we need to make sure that Webpack to kind of roll up our sleeves and get our hands dirty in these files. And then under source, we see it breaks this up. It starts in this main.js file where we importing Vue and our app component. It set up the router because I probably said yes to the router, and I didn't want to have to set it up later. And then here we say a new Vue. We're putting this in our app elements. We're having the router, and then our template is just our app component. And then here's the components that we kind of render. And then in our app view, so now we have a .vue file. So we're not working in TypeScript or JavaScript. We're writing this .vue file where we have a template at the top. We have our scripts in the middle, and then we have an inline style there. So it reads this file, the template, the script, and the style, and then it'll create a JavaScript file that represents our app component. And I don't think order matters in here as long as it's in component, scripts, and style. And then it has our router set up, so it already set up a base path for hello world. So, but we'll get into the router here in a little bit. And then finally, it's rendering our hello world application since that was our default route in our router. which our template has just a div where we have a whole bunch of links to basically all these add-ons that we can add to Vue to kind of make our application a lot better. And then we see we're doing the template binding here for the message. Here we have data, and then down here we have our style, and then we put scoped in there to limit the CSS to this component only. So it's doing that sort of shadow DOM-y type stuff where these styles will only affect the hello world template. And then assets where we have the logo. So all of three of these give us, just with a couple commands in our terminal, we have an application where we can spin up and kind of get started in any framework. That was pretty easy. So basically, all I did in all of those, I ran the CLI install command, and then cd'd into it, did an npm install and an npm start, and then you have an application where you can start hacking around. And then number two, this is where I create our first component, and then how to bind data from our component into the HTML. So I'm going to come here. I'm going to say get checkout to, and then now I'll collapse all these. So in Angular, I use the CLI to generate a new component for me. So actually, I did not. Next step. So in the app component, I removed everything that was there that they kind of pre-generated for me. And then I added in the index.html CDN to materialize CSS to make my application look a little bit better, since I don't like writing a whole bunch of CSS by myself, so I'll just utilize a library. And then my HTML, we see in our component, I just have a list of cat names. These may or may not be cat names of cats that I own, but they're just cat names. So here we have a list of cat names on our component, and we see that it's rendering our app component HTML. And then in our HTML, we have a div class row, and then I'm creating a column, and I'm using a for loop with Angular template syntax, star ng4. I'm iterating over that array of cat names. I'm saying let cat of cat names. So it creates a local variable inside the scope of this div tag for cat. And then I'm able to interpolate that right here and render that cat name. So it's going to create, and I'll just show the Angular one of this guy because they'll all be the same. While that's loading, and then we have just a card. So it's just going to show basically all the list of cards that we saw before. If I come here, and we see when I load this up, we don't really have a nav bar anymore. It's just different cats. We can refresh and see. That's a weird one. And then we can get a different cat gif each time. And then there'll be sort of the same view for React and Vue. Let's take a look at that one. So with React, what I did is in the app.js, I went ahead and removed all of the default stuff that it gave us, added to the state of this application or this component all the different cat names. So we're creating the state of what we're going to actually render with. And then I have down in my render function here, I have a breakpoint for some reason, I have console log. And then I have a return where I'm rendering a div with the class name row, and I'm rendering all of these cards. So in React, the way that we'll do a for loop to create all of those different cards is we'll actually create them up here with this.state.cat names. So we're going to map over the cat names, and then we're going to call this create card function. And this create card function just returns the HTML where we'll pass in the cat. So we have to create a variable for cards and then render the cards. So it'll create all of that HTML for us, and then we'll kind of throw it here into the row. And then we need to make sure that we do this.createCard.bind this. And then in Vue, I modified the, well, first in the router, I changed it from hello world, and I went ahead and made a cat list component. And then in my cat list component, my template is that same row, or that same column in the cards. But now instead of star ng4 to loop over, we do a v-4, and then we do cat in cat names. So this is the local variable inside of this div, and then cat names represents our data that we have for cat names. And then we're just interpolating that cat name, which is just a string, in the card title. And then down here in our script, we're creating the name of our component is cat list. We have a data for your component, what you're going to be using in your view, and then we're just returning an object that has a property with cat names, which is an array of all of these hilarious cat names. And then I don't have any styles because, again, we're using that materialized CSS. Okay, any questions so far about bootstrapping and creating just a really easy component? Cool.
Going back and forth with three of these, did you build one end-to-end, like an Angular, if that's your, bread and butter, and then go do React and then go do Vue, or did you do like the very beginning part in all three of them, and the next part in all three of them?
Yeah.
The next part?
I did the very beginning one. I always started with Angular because I wanted to make sure that's the one I know the most. So I wanted to make sure, like in this case, that I had the cat list component and iterated over there. Then I went ahead and did React and then Vue. So I made a Git repo for every single one, or all of them, and then so I can commit them pages at the same thing and have different tags. So yeah, I went in the approach where each one of these steps, I did Angular first, and then either React or Vue next, and then the final one. And just a disclaimer, like I'm not a professional on React or Vue, so the code that you're seeing here, it could be wrong. It could be like, there could be a React pro watching this on YouTube saying like, well, why did the dumbass write the template like that? Like, it'd be so much easier if you did it like this. But I sort of took it as an approach like Vue. So I did the old Googles, and I searched on how to do this, and kind of plugged it in the same way. So moving on. So the next one we're going to talk about is routing. So I know my application is going to have routing, so how to set up the router in each of the different applications. So I have to make sure I check out 3, and then go back over to the code. And then in Angular, the first thing I need to do for the routing, it already gets installed via the CLI. It already pulled down into my local node modules folder as the Angular router. And then the only thing I need to do on Angular side is in our app module, I need to import the router module and this routes, which is our just a TypeScript, so we get some IntelliSense when we're setting up our routes. And then I need to set up our routes. So I create an array. So I say let routes, and I type it to routes. So when I type it like this, I'm able to get some IntelliSense right away. So I know I need to have a path match. And then here we set up a default route. So if the route's empty, it's going to head and redirect to the list route. And the list route will render our component, cat list component. And I went ahead and created that default cat search component, which let's see if it rendered. So yeah, so see we have our list route still, and then our search route, which is just a to-do for now. So this is basically all I added in this step. So we set up our search route, which is going to route to our search component. Router, we route to components. So when we do it this way, we're actually setting up our whole application where it's just one big application, and that's what we're going to serve up to our clients and all of that when we build for production. But here we can actually say load children and route to a module. That'll create a lazy loaded route, and then it'll kind of speed up our initial first load. And each of the frameworks will have a way that they support lazy loaded routes by creating these different chunks for features of your application. So if the user goes to your landing page, he's not going to also download all of the JavaScript, HTML, and CSS for feature A, B, C, and D. He'll have to click on a link that takes him to feature A, and it'll download that chunk and then render it on your page. But here, we don't talk about lazy loaded routes or anything like that, but every single framework supports lazy loaded routes. I need to make sure I declare in Angular all of the different components that I'm using inside of this module. And then finally, I need to import the router module, and I say for root, since this is the root of my application, these are all my base routes. I say for root, and I pass in that route config. And then in my HTML, I have a nav bar, and then the way in Angular where we bind to and create links to use the Angular router to go to, when I click on list and search to go to that specific component, we bind to a property called router link. So we see those square brackets as we're binding to a property on that element. And then we have a funky syntax in here, which we're going to the list route, and there's other parameters we can pass in that array for params, query parameters, etc. And then when this router link, we have this other directive on here called router link active. So when Angular router says that this router link is active, it's going to add an active class to this li, which gives us like the nice little background color on there. So our user knows what route they're currently on. And then here we have components for cat list and cat search. And these are just basic components. Like I copied the contents of the app HTML before, and then the same with the cat names. And then our cat search component is just a basic component that doesn't really have anything in it right now. And then in our React app, we see I now have a components folder where in my app.js, we see importing, well, let me go to index.js. So index.js, I had to go ahead and install React Router DOM. So this is an add-on package that I had installed manually. It didn't come for me with the starter. And then in my index.js, I had to import the hash router. It also has like a browser router. So if you wanted a hash location strategy versus like an HTML5 location strategy where you didn't have the bang symbol in your URL, here I'm just using the hash router. And then in my entry point, I'm wrapping my application inside of the hash router. And then in my app.js here, I have all of my components here that I'm going to be routing to. I have a nav, and then in my nav, we see in these LIs, instead of anchor tags, I'm now using nav links, and this is going to go to the slash route, or this is going to go to the search route, and you can give it an exact because everything will match slash if you're on it. And then we can give it an active class name, so it'll put it an active that active class name when that nav link is the actual active route that we're on. And then finally, we have a main tag where we have a switch. So we have a switch based on the path of the route that we're going to, and then we render this component. And then our cat list is basically what we had before, just in a new component now. So we still have our same create card, our cat names, and then our render function with the cards. And then in the cat search, it's just a very basic component where we just render that div that says to do. And then finally in the view, I also, well, since the CLI asked me if it wanted to set up the router, I said yes. It automatically installed this view router for me. So if I said no to that, I would have to install this manually. And then in my main.js, I import my router setup. So from the router folder, and then I go ahead and add it to my main view component. And basically we just say new view, and this is the root of our application. And then under router, here's where we set up the different paths of our application. So we import router from view router, and then with the view, the way they have Babel set up, they actually have some cool import paths and like some quick and easy things you can do, so you don't have to do a whole bunch of like dot dot slash and go up. You can just say at components. And you can do this in any of the other frameworks. You'd have to set it up in Webpack or set it up in Babel, and then you'd be able to do that pretty easily. And we tell Vue to use that router. So Vue actually has this like extension or add-on framework in it. So we say Vue use, and then this router is actually an add-on. We're saying, hey, use this add-on, and it sets up a whole bunch of stuff in the internal Vue library. And then we say export new router, and then this just has routes where we're going to / redirects to list, lists renders the cat list component, and then search renders the cat search component. And then in our view, we have, in our app view, we have the div that renders our application. We have our nav bar. So now, instead of anchor tags or the nav link, a tag called router link, and then we're going to /list or /search, and then Vue automatically adds router this class name down here for router link active as like a router link exact active, and all of those classes automatically get added for you. So that's pretty cool. And then we have our router view. So all the components we're going to route to, it's going to throw it here in the router view for us. Just look like they did before with our template for our cat card and our cat names, and our search is just very basic that has a to do. And there's no data right now. And then when we go to HTTP, so now we have a basic component, we have our router set up in our application. Now we need to actually communicate to our backend somehow. This is tag 4. I'm going to check out tag 4. Okay, so we'll jump to Angular first. So again, Angular automatically added this because it assumes you're creating an Angular application. You're going to use router, you're going to use HTTP, you're going to use all these basic things. So they go ahead and add it for you. And then in my app module, I need to make sure to import the HTTP client module. And then I go ahead and set it up as an import on my ng module. This is basically saying that this app module, during the context of this application, I'm able to dependency inject all of the HTTP services. I'm able to use any of the built-in directives and components that this whole module defines for me. In my cat search, so my cat search is where I'll actually be doing all of the wiring up. So if we take a look at it before, so now on search, which, let me start it again. While that's starting up, we'll jump into it. So in my TypeScript file, I have an import for HTTP client. So, and this comes from Angular Common HTTP, and then I'm able to inject the private HTTP client. So with TypeScript, this private is just a modifier that will automatically do. It'll create a property for us on here. So like I didn't have to and I didn't have to say this.htp equals HTTP. Like doing that private modifier on there automatically did all of that for me, so it saved me a few keystrokes. And then we give it the type HTTP client because Angular dependency injection actually looks up based on the type. Since we imported that HTTP client module, it rendered all of those providers that module gives us, and then the dependency injector will go and say, hey, I need a type of HTTP client. It'll go look at all of the modules you have defined, all of the providers can actually give you back the singleton that it's set up for that. And then in the HTML, we'd have just a basic card. We have one card on this guy. We're binding to the source property of this image, and then we're binding it to cat image source, and then we're just defaulting it to the cat API, and it just renders a basic GIF at the very first. And then we have a button where we're binding to the click event on that button. So when someone clicks that button, we're going to be calling generate new cat, and then generate new cat will fire a call into the HTTP. So we say this.http.get, and then we're actually calling to this dog CEO library that will give us a random dog image. And then in Angular, the HTTP, everything's an observable. So here, and if you're familiar with promises, instead of doing .then, we subscribe to that observable. And when that data comes back, we're just going to set it back to the this.cat image. We're going to grab the message off that data. So now it should be loaded. So now we see we have one really, really big cat GIF. And then when I hit this button to refresh it, now we see it gets loaded to a dog image. And then I can keep refreshing this. It's going to do an HTTP call to that API, a dog image, and then it re-renders in that image tag. So we see we have that binding to HTTP and then re-rendering that data on our view, which I don't know why they're so large, but oh well. And then if we look at what we had to do with React, so React didn't have anything built in for the React HTTP. You can basically use any based HTTP library that you want. I went with this Axios library. And then with that, in my source, under my cat search, so I didn't have to do any wiring up inside of my main application like we did in Angular. I didn't have to import that HTTP module. Only in my cat search, import Axios from Axios. So this will be whatever library that you want to use, you can use here. We have a same div down here where we're rendering, where we're binding to the source of that image based onto the state. I populated the state of this component with the initial cat image. And then when the on click of this button, we're calling this.generateNewCat. And then this.generateNewCat basically calls Axios.get, which fires that HTTP call. And then this is promise-based. So we do a .then because the promise resolved. This gives us the response. And then I say this.setState to propagate it back from this HTTP call to the DOM, and it will all re-render. So we'll click the refresh button, and it'll render a dog image for us. And then finally, in Vue, I had to install this Vue resource add-on. And this Vue resource is sort of the default go-to library for HTTP stuff in Vue. In my main.js, I didn't have to do anything. Oh, I'm a liar. In my main.js, I did have to do stuff. I imported a Vue resource from Vue resource. And just like we did with the router earlier, like registering an add-on, we say vue.use, and we pass in that Vue resource. And this kind of gives us some new methods and variables inside of our component scope that we can use and actually do HTTP calls. So now in our component cat search, we have the same template we've seen before. Now we're using vbind. We're binding to the source with the cat image source, and then we have the same. We're listening to click events with v-on and then :click, and this calls generate cat method, which we say since we did that vue.use Vue resource, this gives us a $ HTTP object onto the scope of our component, and then we're able to get do a get, you can do put, post, delete, all of those HTTP verbs and all of these libraries you can do. And this is also promise-based. So we do a .then, we get the response, and then we do response.body.message. We set it to the cat image source, and then it renders, re-renders as a dog image. Any questions? Yeah.
So in that case, is $HTTP to some magic thing you created, or is it kind of like Angular 1, where you could kind of name that somewhere? We call that.
It automatically came in when we did this Vue resource, and they have an add-on structure where basically like when Vue creates new components, it'll automatically like add a whole bunch of those properties for us, and it gives us that $HTTP. Alrighty, so that kind of just takes us to the end of it. That was really all. I just wanted to add all the main pieces of the application: routing, HTTP, simple binding, listening to events. I had really fun building all of these things. If I had to rate them, Angular obviously is my favorite. Wouldn't be the owner of this meetup group if I didn't really love Angular. So I would say Angular's #1. I really loved writing in Vue. I found it very intuitive to learn and pick up. It was a little bit frustrating at times because like writing Angular for so long and doing TypeScript, I was trying to do a lot of TypeScripty things in Vue, and it did not like that, but it actually rendered my stuff, and it didn't. Like, for example, here in my cat search, I had this as an arrow function, and it worked just fine. It just, now I broke the scope of that component. And I created like a new internal scope, and it doesn't like this syntax, but it rendered just fine. But when I clicked the button, nothing happened. I couldn't figure out how to get this HTTP, and it turns out like you're supposed to write it like this, and then everything just magically works. So there's a couple of pain points, but I really liked sort of how it broke all of this up. And Vue does some really cool things with like on click, and there's some modifiers you can put on here like .once, and then it'll only ever fire that one time, and it'll kind of just unbind itself. And there's a whole bunch of other things you can do like .control or .shift to make sure the shift key is also down. So I thought the way that they did their template binding was pretty cool, but it is a lot more verbose than what Angular gives you. Angular, with their template binding syntax of just brackets to binding to properties and parentheses to listening to events, to me that's a lot more intuitive to, like, I just need to know my DOM APIs, which if you're a front-end developer, you've been using those for a long time. With Vue, you have to know all of these Vue-specific things. So this seemed very like Angular JS-y to me, where it had all those different directives that you had to understand and know how to use to be very proficient in the app and in the framework. I really liked how it was all set up. React did not like that one bit. I think I always did that one last. I was dreading it, but I just can't get over the way that they write their templates, and it's just like return parentheses and then the HTML. Maybe it's because like I don't have my editor set up correctly to format it. Like every time I saved it, my formatter's just made a whole mess of it. Like I think I can show you what happened. It's mainly personal preference, but like if I change this and I saved, I like did all of this stuff, and I had to turn all of it off, and I was super frustrated with it. But yeah, it could just be I don't have my IDE set up. And then, like I said, this is how I Googled, and like the tutorials went me through this. There could be a more advanced way of doing this that's way more intuitive to use. But this is the route I went down.
Have you counted lines of code in each of the implementations?
Oh, I did not. But we can just look at this cat search, right? So there's 43 lines of code in cat search. There's 39 in the Vue. And then in the Angular app, we have 23. But this broke up the HTML, which is another 12 or 14. So all about like 35 to 43 lines of code for each one. But with Angular, you have to make sure you register each of your components as on the module. In Vue, you need to make sure to, when you're setting up your router, import all your components and you register them there. So there's always some place where you're going to be like keeping track of all your components and registering either with the router and all of that kind of stuff.
Do you have an example of a test?
I was going to do that, but I didn't get around to it. The test that you'll write for Angular, like we'll just look at the generated ones that they gave us. So under app, so Angular, when you're writing tests in Angular, we have this, comes with this test bed where you're going to configure your test module for what you're going to be testing. And then here you basically do the same thing what you're doing in your module system. You have to declare the components that you're using. You have to declare the components that the component you're testing is using, so it knows how to create that module. You'll have to set up your providers and all of that if you inject things in. And then from there, it's just you create the component instance off there, and then you can test to see like if the app.title is equal to app and stuff like that. In React, it did generate one for me. I did delete it. It was basically the same thing. Like it has like a React DOM, really React DOM sets some stuff up. You render a component, you grab the instance, and you test things on. I did not see any sort of testing around Vue, so I kiboshed the testing one. But it'll be basically the same thing. You'll set up your component, and typically here at Bullhorn, we don't, when we're testing our Angular stuff, we don't really go through and create these test beds because we have a really robust end-to-end testing framework that tests to make sure our components render and do things the way they need to do. So we really only test like if we had methods and setters and getters and all of that on our component. We just spin up our classes, create new instances of them, and make sure that our functions return the way they need to. Yeah.
I assume that the Angular implementation was the easiest one for you to do.
Yes. I didn't have to look at any documentation.
Of the React and the Vue, which did you find easier?
Vue. They had a really awesome documentation website. CLI was really easy to use and understand. React, I found myself jumping to like not using the documentation on React. I used like a lot of Medium articles to kind of help me do this stuff. But with Vue, I was just in their documentation the whole time. So I found it very easy to follow.
React doesn't have good documentation, or just because the blog sphere has so much good stuff?
It's probably a mixture of both, because like when I searched for something, like the blog post came up first, and then like the documentation was further down. Vue's so new, there's not as many blogs written in Vue to kind of go through these, so I was stuck in the documentation. So kind of half a dozen the other.
So I know you're just one opinion, but why do you think React is so popular? You say because it's just startups and stuff. There's startups.
I don't know. Like personally, like when I was writing it, I was thinking in my head, like, how does anyone code in this? But I shouldn't have said that because now it's on YouTube. But like I'm an Angular diehard. Like, I teach Angular classes on the side. So like for me, it was very hard to write all of like get past the syntax of how to write it. So it's always been like in the back of my mind, like I never really liked React. So it was hard to change my mind when I was actually writing an application.
Predate the others?
I would say like it predates Angular, but it doesn't predate AngularJS. So AngularJS was the first one, and then React came out. But React has done a lot of great things, like with like the release of Fiber, which made it super fast, and then Vue is definitely the newest one.
couple of things. I did a online where I was kind of learning about like, testing part of it, and I can add the link to my repo on the forum, on the GitHub forum. Those who's asking about the testing.
Perfect. So,
and then with React, the thing that's hardest for me, what has been the hardest for me to get is like the more complex state management or deconsolidation. Vue has UX,
yes.
for the state management. How does Angular do state?
So Angular has basically the same type of thing. It's called NGRX. So it's like the state management store where you have actions and reducers and all of that to kind of manage the central state of your application. Basically, yes. So if you're familiar with one, it'd be easy to pick it up on the other one. Do you have a question?
Oh, I was just gonna help people read through the lines that if you use Angular a lot, you get used to TypeScript. The reason you stay with it is because of the development experience.
Yes.
It has a lot less to do with what the end result is, but it's way easier to use. You get IntelliSense, you get, once you start, you're like a master chef. Like you can operate a kitchen with your eyes gouged out of your head because you have structure and systems set in place. You know how everything works, that you just go. That's kind of the experience that I had when I was doing TypeScript. Switching to Vue as I've had to do here in the last couple of months. Don't have that level of like professional chef kitchen structure. You kind of have to create that for yourself. It's a very DIY framework, which is great for some people to start with. But if you are in it for the sake of, I need to learn a framework really well because my ultimate goal is to be able to use this in a very, very high capacity, you might shoot yourself in the foot if you try to learn the easiest one first, waste that time, and then figure out that's not necessarily the right tool to get me to where my original goal was.
Yeah.
You say that that's...
Yeah, I'd say that's correct. And like if a React expert were to do the same talk, he'd probably have the same feelings, but on Angular. He'd say like, oh, this is so much to set up and all of this, like I couldn't just do this and that. And the same with Vue. So this was sort of a comparison of frameworks, but very biased versus Angular. So huge disclaimer on that one. Any other questions? All right. Well, thanks everyone. Thanks for coming. We appreciate it. The December meetup is on the books. I think we're going to talk about progressive web apps and how to do them in Angular. We'll probably even show some do their progressive web apps as well. So hope to guys see you there. Thank you.
Real fast, everybody, too. This is Josh's favorite part of the meetup. I'm the manager of content acquisition at Bullhorn, and it would be worth